This is Honors Geometry Lesson 8.2, Properties of Parallelograms. So the best thing you could do in this lesson is just use common sense. So here's a parallelogram, and I'm going to ask you 3 things you notice about this parallelogram. So maybe you say, hey, I can see that opposite sides are parallel. You're right. By definition of a parallelogram, opposite sides are parallel. Then you might say, hey, I noticed that opposite sides look congruent. You would be correct. Opposite sides are congruent. What about the angles? Maybe you notice that opposite angles are congruent, and you are correct. And we said that opposite sides are parallel. If opposite sides are parallel, we know we have a pair of CIA angles, consecutive interior angles, so we would know consecutive angles are supplementary. They would always add up to 180. And maybe you didn't think about the diagonals, but if we draw in the diagonals of this parallelogram, you can see that they're not congruent. We have a short one. Anytime it's tilted over, you have a short one and a long one. But what maybe you can notice, even if my lines were straighter, is that the diagonals bisect each other. So that's the last secret. 2 diagonals bisect each other. So here's the official theorems. The first one is by definition. By definition, a parallelogram is a quadrilateral, so we know it has 360 degrees. With both pairs of opposite sides parallel. So any of the rules we know about parallel lines will apply to this parallelogram. The first one they talk about is that opposite sides are congruent. And then as we noticed, the opposite angles are also congruent. By the fact that we have parallel lines and consecutive interior angles, we know that they're going to be supplementary. And then what we talked about, the diagonals bisect each other. So those are our rules for our parallelogram. So we're going to use those rules to solve simple problems. So we know, given that this is a parallelogram, we know opposite sides are congruent. So if this side is 9, I know this is 9. If this side is 15, I know this side's 15. Throw in a little algebra. That's not going to hurt us. We know that m plus 1 equals 6, so m must equal 5. And obviously n would equal 12. We know that opposite angles are congruent, so in this case we know a is 55. Opposite angles, throw in a little algebra, we know that 2p equals 120, therefore p is going to be 60. Okay, and again, opposite angles, opposite sides, opposite angles, opposite sides. Let's throw in consecutive angles. Now we're looking for angle B. Obviously, they're not congruent. There's no way angle B is 51, but we would know angle C is 51. You can say all angles are 360, add those together, subtract from 360, subtract, and divide by 2, see what you have left over. It's much easier to say, hey, I know consecutive angles are supplementary, so I'm going to take 180 minus the 51, and I can see that my missing angle must be 129. And the same thing here. We know these two together equal 180 minus 95. This angle must be 85. Let's talk about diagonals. We know the diagonals are not congruent, but they do bisect each other. So I know this is congruent to this. I know this is congruent to this. So I say b minus 1 equals 9, therefore b equals 10. And then I say 5a equals 15. Divide each side by 5. I can see a equals 3. To make it a little more interesting for you, I threw it in a linear system. So I know that 2y minus 4 equals 4x. Uh-oh, we have 2 different variables. I also know that y, I know that this equals this, I know that this equals this. So I also know that y equals x plus 4. So we're going to solve this. I'm going to use substitution. Whenever I have a variable by itself, it looks like it's going to be an easy substitution problem. So I'm going to take this and I'm going to substitute it in for y. Remember, the idea is to get rid of the second variable. We only want one variable. So I'm going to say 2 times, I'm replacing y with x plus 4, minus 4 equals 4x. Distribute my 2. I'm going to combine my like terms. 8 minus 4 is going to give me 4. I'm going to subtract 2x from each side. Divide by 2, so it looks like x is going to be 2. Now that I know what x is, it's easy to find y. I'm going to take that 2 and put it in for x. So I'm going to say y equals 2 plus 4, or y equals 6. I just solved using substitution. If you prefer elimination, certainly use whatever method you're most comfortable with. Let's check my work here. So I have x is 2, so 2 plus 4 is 6, and y is 6. So both of these are 6, so far so good. 2 times y, that's 12. 12 minus 4 is 8, so this side is 8, and this side is 4 times x, 4 times 2, that's 8, looks like it works. All right, please, I threw in one more just to make it a little more interesting. So what I like to do is just find all the angles I know, and then I go back and fill in the blanks. So we have 60 here. I know vertical angles are congruent, so I'm going to put a 60 here. I know I have a linear pair. A linear pair is supplementary, so I take 180 minus the 60 right here. So I know this is 120, which makes this 120 because they're also vertical angles. I know I have 2 parallel lines cut by a transversal because I'm given that this is a parallelogram. That's what that symbol means. So I can carry this 45 up here. Just make room for it. So alternate interior angles, I can carry that 45 over to here. And I can carry the 85 over here. These are parallel lines cut by a transversal, so I also know this angle is 85. Now I know that these two angles together equal 130. I know consecutive angles are supplementary, so if I take 180 minus 130, I know this angle is 50, I know this angle is 50. And then we can split that. We don't know that it's split in half, but we do have a triangle. So let's look at that triangle right here. I have a 60 and an 85. 85 plus 60. I'm going to take 180 minus 145. So I know that this angle is 35. And we said together the two have to be 50. So that makes this angle 15. Carry it up here. This is 15. This is 35. Please try the practice problems. Let me know if you have any questions. Thank you.